Hi students, today we are going to study a geography chapter. It is titled Minerals and Energy Resources. This chapter contributes uh, almost 3 marks. It is 3 marks. The contribution of this chapter is 3 marks to the board examination. This chapter is a very important chapter. All throughout this chapters of geography, we are studying one concept, that is basically resources. So we are going to study minerals and other energy resources in this chapter. So first of all, let's read a small case study given here. You can just see Haban comes to Guwahati with his father from a remote village. So when he saw some buses, trains and all passing, basically he is from village, he is asking why don't we have a house like this with the wheels which can be moved everywhere. So the father is actually making the child understand that this is not actually a house like ours. This is at another thing like buses and trains, etc. So he also states that our house is made up of bricks and other things available in the village, but buses, trains, etc. are made up of metals. So we are basically going to study about metals, minerals, as well as some energy resources that is available on earth, especially that are seen in our country. Okay, so minerals are unavoidable or indispensable part of our lives. You can just imagine, from the small safety pin we use to the rockets, cars, buses, everywhere there is minerals. So there is nothing which is devoid of minerals. You are going to study that even in our human body we need 0.3 percentage of minerals. Okay, so this 0.3 percentage minerals are highly required, otherwise 99.7 foodstuff will not have proper function in our body, isn't it? So whenever we buy packaged drinking water, we look for minerals inside that, otherwise that water is of no use. Fine. Now let's see some examples to see the importance of minerals. There is a bright smile from toothpaste and minerals. So the simple toothpaste that we use, let's see how many kinds of minerals are included. Abrasive minerals, abrasive means the rubbing cleaning minerals are included, like silica, limestone, aluminium oxide. Okay, so various phosphate minerals, so they do the cleaning work in a toothpaste. Fluoride, which is used to reduce cavities, comes from a mineral fluoride. Okay, third one, you can just see most toothpaste are made with white titanium oxide, which comes from minerals. Okay, so rutile, ilmenite, you can just see number of minerals from which we are getting so many. See, in short, actually the toothpaste contains number of minerals. The sparkle in some toothpaste comes from mica. The toothbrush and the tube containing the paste are made of plastics from petroleum. So you can find in a small toothpaste how many number of minerals are included. So in our day-to-day life, whatever things we use, So they are all inclusive of minerals. We have already seen the human intake of 0.3 percentage of minerals is very essential. Without them, human body cannot survive. Now let's begin the chapter by knowing the definition of mineral. So what is a mineral? The geologist define mineral as a homogeneous means belonging to same category, same family, homogeneous naturally occurring substance with a definable internal structure. You study in chemistry that everything will have their own structure. You have already studied about the atomic structure of important things. So likewise here, every mineral have there is a definable internal structure when we analyze its structure, and they belong to the same family and they are naturally occurring substance. So once again let us read the definition of minerals. Homogeneous naturally occurring substance with a definable internal structure. Okay, so they are found everywhere on earth. Okay, maybe in ocean, maybe in the land, maybe in the rock systems. Okay, so you will find the existence of minerals in almost every places. Okay, so you already studied that basically rocks are combinations of homogeneous substances called minerals. The rocks, okay, we have different types of rocks. These rock systems are actually a combination of minerals, homogeneous substance called minerals. Let's say some rocks, for example, limestone. Limestone is actually an example which has a single mineral. You know, minerals are actually, when we are analyzing different kinds of minerals, they are a combination of minerals, but there are certain minerals which are exception. Limestone is an example of having single mineral. If we are analyzing, there are almost 2000 minerals have been identified in the world, but only a few of them are effectively used. Now we are going to study about the difference between a geologist and a geographer. Okay, so geographers study minerals as part of the earth crust for a better understanding of the landforms. The distribution of mineral resources and associated economic activities are interest to geographers. So what are the interest of geographers? They actually study the distribution of minerals, okay, and associated economic activity are the interest of geographers. On the other hand, a geologist is interested in the formation of minerals, their age and physical and chemical composition. Maybe one is theoretical geologist who study theoretically about the formation, the age of a particular mineral, okay, and physical and chemical composition. So these theoretical aspects are studied by geologists. On the other hand, geographers just study the different landforms, distribution of minerals, and economic activities like mining. All these things are the concern of geographers. Now let's study classification of minerals. Okay, so let's study the how minerals are actually occurring, how they are coming to existence. Okay, so this is the classification given. So basically you just see the table, the flow chart given here. So generally minerals are classified into three: metallic, non-metallic, energy minerals. Under metallic you can just see ferrous containing iron, example iron ore, manganese, nickel, cobalt, etc. Then non-ferrous, okay, which does not have iron content, copper, lead, tin, bauxite, etc. Then under metallic we have precious metals, okay, for example gold, silver, platinum, etc. We have non-metallic, mica, then salt, potash, sulfur, granite, limestone, marble, sandstone. They are non-metallic minerals. We also have energy minerals like coal, petroleum, natural gas, etc. So this is a classification. Now we are going to study about how they are appearing, where they are appearing. Okay, so the term ore is, minerals are usually found in ores. So what do you understand by ore? The term ore is used to describe an accumulation of any mineral mixed with other elements. Okay, so you have heard about iron ore. So we are not directly digging out iron or copper, etc. They are mostly mixed with slurry, mud, stones, etc. So when they are combined with these other elements, we call it ores. Okay, so minerals are actually appearing in ores. From where we can get these ores? Okay, so minerals generally occur in these forms. Okay, so first one, in igneous and metamorphic rocks, minerals may occur in the cracks, crevices, faults, or joints. So you just see in the rock system in the form of a fault, crevices means you can just see something like veins or lodes, maybe small cracks will be there. Maybe that word will be more easy for us to understand. Okay, so in these cracks, minerals appear in very hard rock systems. The smaller occurrences are called veins and the larger are called lodes. In a metamorphic rock system, if you are found minerals in a very little quantity, it is called that kinds of cracks or joints are called veins. If they are appearing in large quantity, they are called lodes. Okay, so some examples: tin, copper, zinc, lead, etc. are found in this igneous or metamorphic rock system. Another way in which minerals are occurring is in sedimentary rocks. Okay, sedimentary rocks. We studied earlier metamorphic rock system and in sedimentary rocks. Sedimentary rocks, as you studied earlier, they are not so thicker. Okay, so sedimentary rocks, a number of minerals occur in beds or layers. Earlier it was in vertical forms. Okay, almost vertical form like cracks and crevices. Now they are more in horizontal strata. Okay, so they are formed through a result of deposition, through the process of depositing, maybe centuries of years of deposition of things. Like you might have heard that trees, so when they are deposited, so continuously they are deposited, so they undergo millions of years of process, then finally they turn to become coal, okay, and other kinds of costly minerals. So they have been formed as a result of deposition, accumulation, and concentration in horizontal strata. So they appear in horizontal strata. So they appear in the form of beds and layers. Coal and some other form of iron ore have been example of minerals occurring in sedimentary rocks. Other examples are gypsum, potash salt, sodium salt, etc. So these are formed as a result of evaporation, especially in arid region. So we have studied coal and all. Coal and other iron and all is actually created or made through deposition. But gypsum, potash salt and sodium salt and all is found in sedimentary rock system through the process of evaporation, especially in arid region. Okay. Now another mode of formation involves the decomposition of surface rocks. You know, these surface rocks undergo a number of changes, maybe due to wind, due to continuous flow of water, or continuous rain. Okay, so you can just see another mode of formation involves the decomposition of surface rocks and the removal of soluble constituents, leaving a residual mass of weathered material containing ores. Maybe when these surface materials are washed away, eroded away, so there remains a residual mass of weathered material. Okay, all right. So example of this category is bauxite. From bauxite we create aluminium. Okay, now another way in which minerals occur is through alluvial deposits. You know, certain minerals may occur as alluvial deposits in sands of valley floors and the base of hills. Okay, so they are seen in as part of alluvial deposits near to the river beds. Okay, so these deposits are called placer deposits and generally contain minerals which are not corroded by water. So maybe through the flow of water in the river beds and all, they can be found, or at the at the bottom of a hill in the valley side you can find them. Okay, examples are gold, silver, tin, platinum, etc. Okay, then the fifth way of minerals occurring is ocean. Okay, the seas. So you know that ocean is a vast, it contains vast quantities of minerals. Okay, but the tapping them economically in a viable way is very difficult. So certain things already you know, common salt, magnesium, bromine. So these are all derived from ocean waters. So there are five ways of appearing minerals appearing. First of all, from igneous rock system. Then uh, we have studied sedimentary rock system. Then from for undergoing a process of decomposition of surface rocks. Okay, so through the process of decomposition, certain minerals are getting like bauxite and alluvial deposits. They are also known as in other names placer deposits. Okay, and the last one is actually ocean. So ocean is also creating lot of minerals. There is an interesting fact given. It's about northeastern place. It's all about rat hole mining. Northeast India minerals are owned by individuals or communities, not legally. Okay, so but they are individual people are actually extracting coal. Okay, coal, iron ore, limestone, and dolomite, etc. Coal mining in Jawal and Chirapunji is done by family members in the form of long narrow tunnel known as rat hole mining. You can go through that. Fine. India is fortunate to have fairly rich and varied mineral resources. However, these are unevenly distributed. You have studied about resource planning in another chapter. Okay, so you can just go through them and you can find several states like Assam have most of the petroleum deposits, Rajasthan having you know, they have other kinds of minerals. Okay, so we need a planning in a central level to find out what things are where, and they must be used for the country's total development. Concentration of minerals in the ore, the ease of extraction and closeness to the market play an important role in affecting the economic viability of a reserve. You study that whenever we find that there are reserves everywhere, but most of them may not be useful. So we already studied that many minerals are found in Okay, fine. So we had a technical problem in between. So let's continue. Okay, so we have found that even though these things are available, even though these things are available, even though these things are available, so the economical utility of a thing, so must be taken into consideration. So if a particular mineral is used for economical purposes, so it should be so easy for the extraction. Just imagine that particular mineral deposit is found in the mid of the ocean. It will be very difficult. Then closeness to the market. Okay, the thing must be close to the market. The reserve must be close to the market. Okay, then only that reserve will become a utility for the country. Thus, to meet the demand, a choice has to be made between number of possible options. When this is done, a mineral deposit or reserve turns into a mine. So there are famous mines in our country. So when economically they are useful for extraction, when they are closer to the markets, they can be taken to the markets, then only a reserve will turn to become a particular mine. Okay, now let's study the classification of minerals in detail. First of all, we are going to study the ferrous minerals. You remember that classification that we studied in flowchart. First of all, it is ferrous minerals. Ferrous mineral account for about 3/4 of the total value of the production of metallic minerals. Okay, so in our country, 3/4 of the production of minerals are actually associated with ferrous minerals. Under ferrous minerals, let us study first of all the iron ore. Okay, iron ore is the basic mineral and the backbone of industrial development. You can just see when we are studying, there are different kinds of iron. So let's first of all you can just study magnetite is the finest iron ore with a very high content of iron up to 70%. So it is actually used for electrical industry. Then second one is hematite. Hematite ore is the most important industrial iron ore in terms of quantity used. Okay, but has the slight lower iron content than magnetite, 50 to 60%. Okay, so the most quantitatively used iron ore is hematite, but in quality it is less than magnetite. 97% of these iron ores are extracted from Odisha, Chhattisgarh, Karnataka, Jharkhand. Okay, all right, fine. So there is a case study given here. Kudiramukh, you can just read it. I have underlined it. Kudire is a Kannada means horse. The highest peak in the western Ghats of Karnataka resembles the face of a horse. The Bailadilla hills look like hump of an ox, hence its name. Okay, fine. Now you can just see where are the areas these iron ores are found. Major iron ore belt in India. Okay, you can just see basically Odisha Jharkhand belt. Okay, so high grade hematite ore is found in Badampur mines in Mayurbhanj and Kedujhar districts. Okay, Singhbhum district of Jharkhand also has this iron ores. Okay, then Durg Bastar Chandrapur belt, second area. So you can just see hematites are found in the famous Baladia range of hills in Bastar district of Chhattisgarh. So iron ore from these mines, okay, Durg, Bastar, Chhatrapur area, so they are exported to Japan and South Korea via Visakhapatnam port. Third one is Bellary, Chitradurga, Chikkamangaluru, Tumguru belt in Karnataka. Okay, so the Kudiramukh mines located in the western Ghats of Karnataka are a 100% export unit. The ore is transported, this iron ore is transported as a slurry through pipeline to the port near Mangaluru. Okay, so Durgavastar, Chandrapur, then Bellary region, etc. They are all export units. Then we have Maharashtra Goa belt. Okay, so in the Ratnagiri areas, Ratnagiri hilly areas and all, we have mining sites. Though the quality of this iron ore is not so high, they are also used for uh, export purpose. Iron ore is exported through Marmagao port. Okay, we have studied kinds of iron ore, hematite, magnetite, and the places of extraction. So important, please go through them. Please note the pictures given here also. Now we are going to study the another ferrous mineral. It is manganese. Manganese is mainly used in the manufacturing of steel and ferromanganese alloy. Nearly 10 kilo of manganese is required to manufacture 1 ton of steel. Okay, so for making steel, manganese is a very important alloy. So manganese is used. Okay, fine. So you can just see production of manganese showing state-wise share in percentage in 2018-19. You can just see Madhya Pradesh is the largest producer, followed by Maharashtra. Andhra Pradesh, Karnataka, Odisha also contribute in the manganese production. Now, after iron and manganese, important minerals extracted from our country, we are moving to non-ferrous minerals. In the case of non-ferrous minerals, India's condition is not so satisfactory. Main things we already saw: copper, bauxite, lead, zinc, and gold. For the country's development, these play a very crucial role, but their quantity in our country is not so satisfactory. There is a map given, please go through them very carefully. The map actually points out iron ore fields, iron ore mines, iron ore exporting ports, then manganese, bauxite, mica. Important places of extraction. Then exporting ports are given, a very important maps. So please go through them. Different symbols are also used to indicate different minerals and place of export, etc. Please go through them, study them very deeply. Okay, fine. Now we are moving into the non-ferrous minerals. First of all, let's study copper. India is critically deficient in the reserve and production of copper. You can just see, being malleable, ductile, a good conductor, copper is mainly used in electric cables. You know that almost electric cables we find for durability, copper is used. Okay, electronics, chemical industries also use copper. The Bhalgat mines in Madhya Pradesh, then K3 mines in Rajasthan, Singhbhum district of Jharkhand are leading producers of copper. Now, another non-ferrous mineral is bauxite. We already studied through weathering process bauxite is created. Bauxite is actually standing as the raw material for creating aluminium. Okay, so it is from bauxite, a clay-like substance, that alumina, later aluminium is obtained. So bauxite is also very important mineral. Aluminium is an important metal because it combines the strength of metals such as iron with extreme lightness and also with good conductivity and great malleability. Maybe that could be the reason why aluminium alloy is used for creating aircraft, because it is very strong. At the same time, the weight of this is very less. Okay, so you can just see Amarkand Plateau, Michael Hills. So these are the place in which we are having this mineral. Okay, so not so largely. There is a chart given here, pie chart given. Odisha 65% is the largest bauxite producer. Our state is Madhya Pradesh is actually 3%, Maharashtra 6%, Gujarat 9%, Chhattisgarh 6%, Jharkhand 10%. Okay, so the major contributor of bauxite is Odisha. Odisha was the largest bauxite producing state in India in 2016-17. Okay, Panchpatmali deposits in Koraput districts are the most important bauxite deposits in the state. Okay, now let's study about non-metallic minerals. Non-metallic minerals. So before that, there is a box information given. You can just see after the discovery of aluminium. It's a funny fact. Emperor Napoleon III wore buttons and hooks on his clothes made of aluminium and served food to his more illustrious guests in aluminium utensils, and the less honorable ones were served in gold and silver utensils. When aluminium was found out, it became a VIP. 30 years after this incident, aluminium bowls were most common with the beggars in Paris. Now let's study about non-metallic minerals. Non-metallic minerals. Minerals under metallic division we have completed. Now we are going to study mica is a mineral made up of series of plates or leaves. Mica is so much used in our furnitures and all. You already aware. We have already seen the sparkling that is given in toothpaste is also one causative agent is mica. Due to its excellent dielectric strength, low power loss factor, insulating properties and resistance to high voltage, mica is one of the most indispensable minerals used in electric and electronic industries. Okay, mica deposits are found in the northern edge of the Chota Nagpur plate, Koderma Gaya, then Hazirabad belt of Jharkhand is the leading producer of mica. Rajasthan, major mica producing area is around Ajmer. Nellore mica belt of Andhra Pradesh is also important producer. Fine. So now we have got idea about mica also. Then we are moving into rock minerals. One example we are going to study is limestone. Limestone means in the chemistry we study calcium carbonates or calcium magnesium carbonates. So these are all associated. So limestone is associated with these kinds of rock compositions. So they are mostly found in sedimentary rock systems. Okay, so you can just see they are very important component of cement industry. Then for iron smelting also this limestone is very essential. You can find that Rajasthan, Madhya Pradesh, Andhra Pradesh etc. having more contribution, especially Rajasthan is largest contributor of limestone. Okay, fine. So that's all about minerals, and let's study one important point: hazards of mining. I have highlighted for your easiness dust and noxious poisonous fumes. It creates pulmonary diseases like breathing difficulties, asthma, etc. Then there is also fear of collapse of mine roofs that may take away the life of a number of people. The water resources near the region, a mine region is actually always contaminated. Again, wherever mine is there, the land is degraded. That land later on cannot be used for agricultural purposes, etc. Okay, so some paper cuttings are given. Please go through them very carefully for seeing our case studies. Okay, safety standards were not in place. So many things related to the panic condition or dangerous condition of mines are given below. So we need to follow stricter safety regulations and implementations of environmental laws. So they are so essential. Otherwise, if government and authorities who are doing these mining activities, if they don't follow safety measures, it will turn to a killer industry. Now you can just study conservation of minerals. We have studied things like sustainability of development. We need to focus on conservation. Otherwise, for the future, things may not remain. We all appreciate the strong dependence of industry and agriculture upon mineral deposits and substances manufactured from them. Okay, the total volume of workable mineral deposits is an insignificant fraction. That is 1% of the total Earth's crust. That means minerals are very, very less in quantity. The geological process of mineral formation are so slow that the rates of replenishment or recreation are infinitely small in consumption. You studied that in order to make coal and all, it takes lot of geological years. So, mineral resources are therefore finite and non-renewable. Since it takes millions of years to renew and become a new mineral, let's call them all the minerals are non-renewable. Okay. Now, a concerted effort has to be made in order to use our minerals resources in a planned and sustainable manner. Improved technologies need to be constantly evolved to allow use of low grade ores at low cost, recycling of metals, using scrap metals and other substitutes to conserve the minerals. Please remember these points for the conservation of minerals. Fine, let's move to energy resources. Let's study about energy resources. You already know which are the energy resources like petroleum. Okay, so basically energy resources can be classified as conventional and non-conventional resources. Okay, now let's study the definition of conventional resources. Conventional resources include firewood, cattle dung, cake, coal, petroleum, natural gas and electricity, both hydel and thermal. And what are the included things in non-conventional? So they are solar, wind, tidal, geothermal, biogas and atomic energy. You know, firewood and cattle dung cake are most common in rural India. You know, some according to certain estimates, 70% of energy requirement in rural households is met by these two. Okay, the cow dung cake and firewood. But you know that forest areas are decreasing, people are not allowed to enter. Again, cow dung, when it is used for burning, we are actually misusing it because we cannot use it for as a manure, etc. So it also faces a lot of difficulties. Now, conventional source of energy. In India, coal is the most abundantly available fossil fuel. Coal is the most abundantly available fossil fuel under energy resources. We have coal is formed due to compression of plant material over millions of years. In smaller classes you studied how coal is formed. Okay, so decaying plants in swamps produce peat, which has a low carbon and high moisture. It's a process of making coal making. Okay, coal is not made, actually how coal is formed. Now we are going to study just like we studied iron. So there are also categories of a coal available, and their categories based on their quality. Lignite is a low grade brown coal. So mostly Neyveli areas of Tamil Nadu we can get this lignite. So they are used for generating electricity. Now, coal that has been buried deep and subjected to increased temperature is called bituminous coal. Bituminous coal means it's actually very high quality coal. They are mostly used for commercial purposes, for metallurgical industry, etc. Okay, so for metallurgical industry we are using this bituminous coal. But you know, the highest quality coal is known as anthracite. It is the highest quality hard coal. It's also written in India, coal occurs in rock series of two main geological ages, namely Gondwana, a little over 200 million years in age, and tertiary deposits which are only about 55 million years old. You just see how long it takes to form coal and such kind of deposits. Gondwana coal, or which are metallurgical coal, are located in Damodar Valley, West Bengal side. Jharkhand, Jharia, Raniganj, Bokaro steel plant area and all are important coal fields. Okay, Godavari, Mahanadi, Son, Wardha valleys also contain coal deposits. Then tertiary coals occur in northeastern states of Meghalaya, Assam, Arunachal Pradesh, Nagaland, etc. Okay, so even you can just see Madhya Pradesh also we have coal deposits. In Singrauli, Widen region we have coal deposits. Distribution of coal, oil, natural gas. is given in the given map. You can just see there is also natural gas pipeline moving. So our CNG pipelines are moving, that line is also given. Then coal mines, coal fields, oil fields, okay, major natural gas reserves, etc. are given, shaded and given here. You can just go through them. Okay, fine. Now let's study about the second energy resource, petroleum. You know, petroleum is the next major energy resource in India after coal. You know, we are great consumers of petroleum for our vehicles, factories, etc. We are using petroleum. Petroleum refineries act as a nodal industry for synthetic textile, fertilizer, numerous chemical industries. Okay, so something like petroleum industry works as a mother industry. It is basic. Without this, many industries will collapse. Okay. Now you can just see petroleum is already studied. Petroleum is found in fault traps between porous and non-porous rocks. How that last paragraph is actually explaining how petrol is actually found. Okay, petrol is formed. Most of the petroleum occurrences in India are associated with anticlines, fault traps in the rock formations of the tertiary age in regions of holding, anticlines or domes. It occurs where oil is trapped in the crust of the uphold. The oil bearing layer is a porous limestone or sandstone through which oil may flow. The oil is prevented from rising or sinking by intervening non-porous layers. So that is the formation, the geological explanation of how petrol is formed or the crude oil is formed. You can just see Mumbai High, Gujarat, Assam. These are the major petroleum production area in our country. Then Ankleshwar is the most important field of Gujarat. Assam is the oldest oil producing state of India. Then Digboi, Naharkatia and Moran Hugrijan are the important oil fields in the country. Okay. Now we are moving into the next famous energy resource. It is natural gas. Natural gas is found with petroleum deposits and is related when crude oil is brought to the surface. Okay. So let's say it's also a byproduct of crude oil, and nowadays the use of natural gas for domestic as well as for as a energy resource in vehicle, it is becoming very popular. Even in our state, Gwalior and all, we have this pipeline, CNG pipelines are moving. So India's major gas reserves are found in the Mumbai High and allied fields along the western side of our country, having these natural gas deposits. Okay, then also we can find in Krishna Godavari basin. So this natural gas is discovered. There is a natural gas pipeline I have already mentioned. Let's have a reading of this. The first 1700 kilometer long Azaria Vijaypur, then Jagadishpur cross country gas pipeline constructed by GAIL linked Mumbai High and Basin gas field with various fertilizer, power and industrial complexes in western and northern India. This artery provided impetus to Indian gas market development. Now it is increasing. You can find almost everywhere its chains are actually developing. Okay, so natural gas will be one of the future energy resources for our country. Fine. Now let's move to electricity as an energy resources. Electricity is generated mainly in two ways: by running water, which it drives hydro turbines to generate hydroelectricity, and by burning other fossil fuels such as coal, petroleum and natural gas to drive turbines to produce thermal power. So hydroelectricity and thermal power are the two major sources of electricity in our country. Hydroelectricity is generated by fast flowing water, which is a renewable resource. Okay, so this is a renewable resource and we are depending our electricity needs basically in hydroelectricity. Bhakranangal, Damodar Valley Corporation, then Kopili Hydel project are very famous hydroelectric power projects. Thermal electricity is generated by using coal, petroleum, natural gas, etc. The thermal energy is also becoming famous. We have our power plants depicted here in the given maps, very important. Okay, so we have nuclear power plants and thermal power plants. So they are given in two symbols. Okay, so just to go through them, which are the famous nuclear power plants and the thermal power plants of our country. We have a number of them, especially the thermal power plants. We have very few nuclear power plants only. Okay, now let's move to another paragraph. Non-conventional sources of energy. Today the need of the time tells us that conventional source of energies will die out soon, like petroleum, fossil fuels, etc. Now we need to focus on non-conventional sources of energy which are actually more durable, or they are renewable in nature. Okay, for example, solar energy, wind, tide, biomass, and energy from the waste materials, etc. So these are actually future sources of energy because they are renewable also. India is blessed with an abundance of sunlight, water, wind, and biomass. So there is a lot of potentiality for us to use these. Let's study about nuclear or atomic energy. It is obtained by altering the structure of atoms. So you have already studied in your science that there are two atomic processes. Okay, fission and fusion. All right, so you have already studied. So we are, by altering the structure of atom, so we are actually creating electricity through nuclear power. Okay, so heat, when such an alteration is made, much energy is released in the form of heat, and this is used to generate electric power. Uranium, thorium, which are available in Jharkhand and the Aravalli ranges of Rajasthan, are used for generating atomic and nuclear power. Then monazite sands of Kerala is also rich in thorium. You need to remember that sources of this atomic energy. Solar energy. India is a tropical country. It has enormous possibilities of tapping solar energy. Photovoltaic voltaic technology converts sunlight directly into electricity. So many of you have the solar panels and all. You have seen that how electricity is produced. It's a great opportunity for a country like us, like ours, to tap electricity from solar or solar energy. Okay, now another thing is wind energy. India has great potential of wind power. The largest wind farm cluster is located in Tamil Nadu from Nagarkovil to Madurai. So when we are traveling Gwalior to Ahmedabad in bus, you can find in the Aravalli hill ranges these windmills are located. So Tamil Nadu, we can find huge length of these windmills. So it's a very future energy source for our country. You must have heard about biogas. Shrubs, farm waste, animal and human waste are used to produce biogas for domestic consumption in rural areas. Okay, so the plants using cattle dung, the biogas plants using cattle dung are known as gobar gas plants in rural India. So we have this biogas is also a very great energy, especially for the rural population, for their kitchen, for their cooking purposes, etc. Okay. You can go through tidal energy. Oceanic tides can be used to generate electricity. Floodgate dams are built across inlets. During high tide, water flows into this inlet and gets trapped when the gate is closed. After the tide falls outside the floodgate, the water retained by the floodgate flows back to the sea via pipeline that carries it through a power generating turbine. So this is also a kind of tidal power. So this tidal energy is actually will be a future energy source. We haven't started to use it. Okay, maybe in India the Gulf of Khambat, the Gulf of Kutch in Gujarat on the western coast, and Gangetic Delta in Sundarban regions of West Bengal. They provide ideal conditions for using this tidal energy. Hope that in the future we can use this tidal energy and all maximum. Then one another possibility of creating energy is geothermal energy. It refers to the heat and electricity produced by using the heat from the interior of the earth. So when you studied in smaller classes, you studied that as you are moving interior part of the earth, the heat of the earth is actually increasing. Okay, so geothermal energy exists because the earth grows progressively hotter with increasing depth, where the geothermal gradients is high. The temperature are found at shallow depths. Groundwater in such areas absorb heat from the rocks and become hot. It is so hot that when it rises to the earth's surface, it turns into steam. This steam is used to drive turbines and generate electricity. So you can just see one is located in the Parvati Valley near Manikaran in Himachal Pradesh, and the other is located in Puga Valley, Ladakh. So maybe in the future we may be able to use more of this kind of energy. Alright, so when we are moving, last point, it's about conservation of energy resources. India is presently one of the least energy efficient countries in the world, but in case of population we are increasing in so high number. So if we don't change ourselves into non-conventional forms of energy, it will be very difficult for the future generation to survive. So with a catchword, let's wind up this chapter. Energy saved is energy produced. So students, we have completed this chapter. We have covered two aspects: minerals, and we have also covered energy resources. We also studied about the importance of conserving resources and moving to maximum non-conventional energy resources. Please go through the chapter very well and get prepared. Thank you.